Hello and welcome again to Haybridge Maths Department A-Level Maths Year 2 Pure, where we're once again working our way through Chapter 5 Radians. We've moved on now to Section 5.4, which once again I'm going to break up into two videos. We're going to be looking at solving simple trig equations in radians in this video, and then we're going to be looking at solving more complicated trig equations where we might use identities in the second video. But the primary aim of doing this is to practice solving trig equations where we do it in radians. So let's have a look at the examples that we're going to be doing today. Now, the way I'm going to do this, I'm going to do the three examples from the book, but I'm going to do it in a my turn, your turn, my turn fashion. So I'm going to do the first one. I'm going to let you have a go at the second one. So I'd like you to pause, try that question, and then the last one I will do, and then you take the notes down. And then that will be it for this video. And in the second one, you'll be able to see how to do, as I've said already, one involving identities and one where you've got a multiple of theta. Okay, so let's get on and do this first equation where we're going to solve sine theta equals 0.3, and instead of doing it in radians, as we've just been speaking about, what I'm first going to do is I'm going to solve this equation in degrees. Make sure your calculator is switched back to degrees if you're going to do this yourself, but I'm going to show you how we do it in degrees because I know that you're familiar with using degrees. So let's use degrees first of all, and then I will do it in radians so that you can see how the two working in degrees and working in radians. Very, very similar, very straightforward way to do it. So without further ado, let's get on and solve sine theta equals 0.3, where theta is between 0 and 360. So the book does this different. The book uses the cast diagram way. We don't like the cast diagram way. We never use that. We don't speak about the cast diagram way. We do all of our questions when we're doing this using the graph. So let's get on and do it. So, and sketch a graph. Let's sketch a graph of sine between 0 and 360. So if you remember, sine looks like this between 0 and 360. So there's 0.3. So if I do the inverse sine of 0.3, it gives me the principal value, which will be this here. You'll also note that we'll have a second value here. This point here at the moment is 180 degrees. So the second value we'll get by taking it away from 180 degrees. So let's go to our calculator again. Make sure we're in degrees, not radians here. Principal value of 0.3 is theta equals 17.5. And as I've said already, the second value is going to be equal to theta equals 180 minus 17.5, which is 163 if you round to 3 SF. Hopefully that's good revision for you. Pause the video now, make notes on that, and then let's have a look at how we do this in radians. So let's draw the graph. out once again. The shape of the graph doesn't change just because we're in radians, but of course now here's 2 pi, not 360. Here's pi. We're still talking about 0.3. Believe me, that does say 0.3. And I don't think that made it any better. Let's look at this and look at this value here. In fact, I'm so offended by that 0.3. I'm going to write it in again. How about that? Slightly better. Okay, but the point is we're going to have to work out this value, the principal value here, by doing inverse sine of 0.3, making sure you've got that little r. We're in radians now. Make sure you change your calculator into radians. Do inverse sine of 0.3 and you should get 0.305. Oh, isn't that value, that 0.3 and 0.305, quite close to each other? Maybe we'll be calling on that in a lesson not too far from now. But anyway, so that's our first value here. This is this value here. What we're interested in now is this value over here. And the way that we do that, instead of doing 180 minus theta, what we're going to do this time, because we're in radians now, is going to do theta equals pi minus 0.305, which is 2.84. So there you go. That's how to do a very straightforward equation in radians instead of degrees. Now it's your turn. What I'd like you to do, usual trick, pause this video. I'm going to flip over to the next video, next slide even. You pause the video again, have a go at that, and then watch how I do it and see if you agree. So pause for now and restart and pause again and have a go at this. Okay, you should have restarted the video now after trying to solve that equation. Let's have a look at how we're going to do it. And the first thing that we're going to do, which I hope you did, was rearrange this. Rearrange this so that you get cos theta equals 2/4, which is a half. Then we're going to sketch out the graph of cos theta. There's my cos graph between 0 and 2 pi. Then we're looking at a half here. And we'll look at that value and we'll look at this value here. So this time, the way that we're going to get our two values is we're going to do inverse cos of a half, inverse cos of a half, and that will give us our principal value. And then our other value we will get by doing 2 pi minus our principal value. So that's the way it works with cos. So if you do inverse cos of a half, or you know it as an exact value like we did in a video not so long ago, you get pi over 3. And the other one that you get is 5 pi over 3, because that's 2 pi minus pi over 3. Okay, so give yourself a big tick if you got that. If you didn't, correct what you've done. And then let's have a look at this example here. Okay, in this example, we're going to have to do a little bit of rearranging. It's slightly more rearranging than what we had last time. And of course, we've done sine, we've done cos. It's the turn of tan now. So let's take away that 3 from the 1 and divide by 5 so that you get tan theta minus 2 over 5. Then let's draw out the graph of tan between 0 and 2 pi. There's your first little asymptote. There's your second one. And there we go. Just about legible of what we mean here by this. Of course, this value here is pi. Here's pi over 2 and 3 pi over 2. So now, if we do minus 2/5, what we're looking at will be, here's minus 2/5. We're looking at that value there and that value there. Don't forget, that's 2 pi there. Okay, so let's get on and work this out. Now, if we find the principal value of tan of minus 2/5, then what you get is that tan inverse of minus 2/5 is minus 0.381. Okay, which means, but it's the one outside. It's as if we came down here. It's going to be the one just there. It's going to be minus 0.381. It's going to be there. That's minus 0.381. So how are we going to do that? Well, we're just going to add on pi and then 2 pi to that, because we're just shifting that beautiful translatable feature of tan, the fact that you can shift it along pi each time and you get the same curve. You can do a translation. So what we're going to do is the first value is going to be theta equals pi plus minus 0.381, which is 2.76, and the other value you're going to add on 2 pi. So you're going to do 2 pi plus minus 0.381, and when you do that, you get 5.90. So it's that problem that the fact that when we do, well, after this value here and this value here for minus 2/5, but when we do the inverse tan of it, it comes out over here, which is outside of our domain. So we use the transformation of tan, the fact that you can add on pi and you can add on 2 pi and it'll give you the other values, just so that you get these values here. Right, I will be back in the next video where we'll do some more complicated examples. We'll do some examples where we get, as I've said already, we're going to use some identities. We're going to use multiples of theta within our equation. But for now, goodbye and see you next time.